Yeah, we can get started. So, hello folks, welcome to Geek Hyderabad event. So, the event is also being streamed on YouTube currently. So, yeah, we can get started. So, hello folks, welcome to Geek Hyderabad event. So, the event is also being. So, yeah, we can get started. So, hello folks, welcome to Geek Hyderabad event. Okay, folks, we can get started. So today we have the speaker Akhil. So Akhil has been the senior consultant with ThoughtWorks for the last 7 years. So he will be the speaker of this events today. So uh, over to you, Akhil.
Yeah, cool. Thank you. Hope I'm audible and everyone can see me. Yeah, welcome to the Geek Night 73. Um, yeah, so the topic that we are going to talk today is about navigating the patterns of microservices. My name is Akhil, and a very brief introduction about me. I have a total experience of like 7 years, and I've been with ThoughtWorks for nearly 4 years now. I've been working for ThoughtWorks Hyderabad all through. And my main skill set includes backend development, infra, and a little bit of front end. I've also had my contributions and in the project contributions towards some data projects, as well as DevOps and infra side of things. So yeah, let's get started with this topic. So here is the brief agenda that we are going to discuss about today. So we are going to start with application architectures and then the application patterns. We are going to see what are the different patterns that fall under application patterns and application infrastructure patterns, and then we are going to discuss few infrastructure patterns. So the talk is mainly going to be inclined a lot towards data consistency patterns than there are a lot more traditional patterns that we can adopt in microservices architectures. But this talk is a little bit highly inclined towards data consistency patterns, and not to confuse between application infrastructure patterns and infrastructure patterns. Infrastructure patterns is what I meant. It's more about provisioning the computational power to the applications that you are going to deploy. And application infrastructure patterns is more about what you are going to set up inside your application. For example, these were a small list that you can see here: cross-cutting concerns, security, communication styles, etc. Yep. And the attention span in the context. I just wanted to talk about this a little. So research has shown that we are losing a lot on the attention span as humans. So what I've done is, the way I've designed the talk is I have segmented the talk into many logical components. So they are really interconnected to each other. Even though if you lose track of one logical component, you will still be able to follow other logical component. So as a whole, it makes sense, and as individually these separate logical segments also make total sense. So don't worry if you are not able to understand few aspects of what I'm talking about. It's totally fine. You will pick up other things that you have worked upon generally, and another thing is about the context setting I wanted to do. So I'm not going to jump directly into many unknown jargons, microservices, patterns, and all. So I am trying to keep the talk as inclusive as possible. So I'll first set a lot of background context so that everyone is onboarded to what I'm talking, and it makes sense to everyone, no matter what is your professional background or what is your experience. So also, I have taken care that you don't need any cloud experience as such. I'm not going to overwhelm you with any fancy terms like lambdas or any cloud native terms and all. So what all discussions that we're going to do today are going to be raw, plain architecture discussions. And I can promise you, if you are not able to follow a few things, at least you will get the vocabulary of microservices that you can take away from this session that we're going to have today. So with that, let's just start going into the context fitting. Yeah. So how many of you are fans of Star Wars here? How many of you follow the franchise Star Wars? Whenever I talk about microservices or Monolith, I love to put this slide. So I mean, you'll connect to this slide if you have seen Star Wars franchise. So a long time ago in a galaxy far, far away, we had this Monolith empire. I have intentionally left these boxes empty here. This you can fill these boxes with a Tomcat server and an Oracle database or a PHP and a MySQL thing. It can be anything. So it is one is a server and the other is going to be a database. So everything that you wanted to build as a monolith stayed together in one application code. You used to deploy it as one application, maintain it as one application. Like things were quite easy. The deployments were easy. Maintenance was easy, but I would say easy only with some few terms and conditions applied. So testability was kind of easy. But what happened when the business grew? What happens when your team grows? Imagine your monolith being handled by a team of like 100 people in your team, and how complex it would grow. What would be the maintainability challenges and what would be the deployment challenges for these things? And then we had a new hope. That new hope is the microservices. Suddenly, the whole development community started thinking from the monolith mindset, and they started talking about decentralizing everything. So if you take a look at a microservice architecture, if you go like 30 floors top onto a building, and if you look down on a microservice architecture, it would look something like this. You have an user interface. You have few microservices. Microservices are nothing but, again, applications, but which deal with a smaller chunk of the whole business domain that you have. So all of these microservices work together to make the application deliver the value for you, the business value. Individually, they might make sense sometimes, and they might not make sometimes. So it's that way. So don't get carried away by the diagram here. We are going to talk about different patterns of microservices going ahead. So this is a very basic representation for microservice. Each service is going to have its own database. And then possibly one microservice can talk to another microservice to get the data that you want to process or anything. And to put in one line, what I can say is, when you're migrating from monolith to a microservice, you are just it solved a lot of problems where it made your development pace of development easier, faster, deployment faster, separation of concerns faster, and scalability and all availability and scalability much higher than monoliths. But again, whatever the problems we had inside a monolith, the microservice has distributed it around it. So the problems we had inside just gotten around the services. And we are going to see how these things are going to affect us, and what are the different strategies that we can implement in our session today. And yeah, this is a little bit of an important slide, I would say. We are going to follow this legend throughout the presentation here. If you're going to see a solid arrow in any diagram, that means we are moving from a pattern which we had concerns, and then we are moving towards a solution pattern. So we discussed one pattern and we saw a few concerns in this pattern. The solid arrow means that the next pattern that we are going to discuss is a solution for this concerns. And then if you see a dotted connection between two block diagrams or two things, whatever you are seeing, they are going to be alternative solutions for the problem that we are going to discuss. Is this clear? I see a couple of chats. Are there any questions, Sumant?
So far, no questions, Akhil.
Yeah, folks, feel free to ask any questions in the Q&A sections area. Yeah, go ahead, Akhil.
Cool. Thank you. So yeah, let's jump into the application architectures now. So what we are going to deal with is now about the monolith. So we just define monolith. We'll take a little bit deeper insights into what monolith is now. So you have the context here. You are building a service, server-side enterprise applications. You have to support a variety of clients like desktop, browser, mobile browser, and native Android and native Apple applications. So you should also be able to expose APIs to the third party, and you might also integrate with other third-party applications. You need to handle HTTP requests, interact with DB, and execute some business logic. Obviously, when you're building a service, a software, you have to have a business logic associated with that. And you have different logical components corresponding to the different functional areas of your application. So this is the context that we have. And when you think of building a monolith for this, so what would be the application architecture? And few things that you have to consider, few factors that you have to consider when going towards making a decision on your architecture. It should be, so it's not like one or two people are going to sit on this application. They're not developing. So it's going to be a team of developers who are going to work on this application. So consider the new people who are going to get onboarded onto the team. And your application must be easy to understand and easy to modify and all. So you should be able to have continuous deployments of your application. So, and then for the scalability of aspects, you should be able to run multiple instances of your application. As the traffic increases, as the load increases on your application, it should scale up accordingly. So, and one predominant thing that always bothers me when making this discussion is about you should be able to take advantage of emerging technologies. And so these are the factors that are going to influence our decision now. So yeah, the first solution, obviously, the thing that you're seeing here, yeah, again, another context. In the right side diagrams that you're going to see in the presentation, whatever is you see in the navy blue color, that is the pattern or the architecture that is under current discussion. And the white blocks that you're going to see is the next thing that we are going to discuss. So currently we're discussing the monolith. So one solution you have is the building a monolith. So you build a Java var file or a single directory of Ruby or Rails, and then a Node.js, or you can have a single .NET nugget. And you just go ahead, deploy it into your servers, and then you continue with your business, right? So if you again look at very basic monolith, it would look like something like this. Your packaging would contain the UI code, the service one, service two. I just wanted to separate. I just wanted to separately show that service one deals with one set of business logic, and service two deals with one set of business logic, but they interact inside. They interact with each other. Not to confuse, these are not two different services. Their communication is within the code, not through any communication protocol. So you deploy this whole var into a Tomcat. Your browser or the client will make requests. It takes data from the database and then it serves, right? So the benefits, again, everything I would put it under terms and conditions apply. It is simple to develop, simple to deploy, and simple to scale. Simple to develop. When is it simple to develop? In the initial stages. Imagine your application, your monolith growing into an application which has like 20 million lines of code. I have seen in my previous experience where few teams were dealing with such huge lines of codes, and it would be so overwhelming for anyone who joins the team. They wouldn't understand. They don't know whom to approach for what, and even to make a small change in one part of the application, you don't know what all things that you're going to impact in the application. And imagine this scenario when you're dealing with 20 million lines of code. So it's not very easy to develop. It's easy to develop only in the initial stages. But then again, I might sound opinionated with this, but there are few teams, few projects, few industries, few companies who have dealt extremely well with monolith applications, but they need a great discipline from the developers in the team, and simple to deploy. Yeah, mostly what you do is upload the var file into your server, and then you're done. That would be simple to deploy, but again, terms and conditions apply. What if your WAR file grows going ahead? It becomes bigger and bigger, and then it takes a lot of time to get deployed. You start facing downtimes for your applications. So it's not very simple to deploy down the line. And the scaling, you can't scale the monolith partially. If you are scaling the monolith, you have to scale the whole application together. If you are creating an instance of your monolith, the whole other instance will have the whole image or whole copy of the image of whatever deployment you are making. So obviously, the computational power that it utilizes is tremendously high. And maybe the kind of scalability that you want in the logic that is being dealt in service one, you might not need it for service two, right? Maybe service one has higher computational complexity, I mean, has a higher logical complexity than service two. So you are unnecessarily scaling service two as well because you are dealing with monoliths. So yeah, and yeah, these things we have already little bit discussed right now, and few things that I missed or scalability can become difficult. And yes, long-term commitment to tech stack. You might know a few companies who have started with their own proprietary languages, built over applications for like 15 to 20 years, and now they're in a position they are stuck with that language. They can't move out. If at all they want to integrate with other third-party acquisitions that are going to make, they have to come up with adapters that would communicate with their proprietary language, and then whatever acquisitions that you're making in. So it's not very easy. You have to commit to a tech stack totally, and you can't. It's not very easy to move away. A lot of architectural changes should happen when you want to move away from a committed tech stack. And yeah, not to mention your overloaded IDE. So how many of you experience once you load the application project into your IDE, it just takes few minutes to load. And then that would obviously piss us off, right? You have to wait until all the indexing of your code has done. And it takes few minutes. And then even when you run or when you're debugging the application, it literally kills your IDE, right? So yeah, that's one concern that would heavily impact on developers' day-to-day work life. Work life, I mean, not the work-life balance, but the work. And then overloaded web containers. Obviously, when you're deploying such huge WAR files, your container might sometimes get overloaded, and a lot of memory leaks would come up, and you have to again start allocating more memories for your containers and all. Yeah. Now, the next pattern that we are going to discuss is the microservice. So it's all about monolith till now, and then we are going to microservice. The context is same. What just we discussed, it's the same context now. Same factors that we just discussed for what we are going to deal with. And then now when you implement microservice architecture, you are going to segregate your whole application into smaller chunk of services that are loosely coupled, but they all work together to deliver one business value, right? So these services will collaborate among each other. The very first diagram we saw about the microservice, where you saw a few microservices communicating with each other and all. So they are loosely coupled and they're cohesive in nature. Again, what I meant cohesive is the functions or business logics or business aspects that are closely related to one another are going to be close to each other, and they're going to stay in a service. And then if you are going to, and then from service to service, you are going to have a proper separation of logical concerns as well as business concerns. We'll discuss going ahead with all this. Don't worry if you're not getting things right now. And scalability, like you can actually scale on the y-axis of the scale cube. So scale cube is one general analogy that we use. Three-dimensional scaling, we call it X scaling, Y scaling, and Z scaling. X scaling is like normal horizontal scaling that you make, and Y scaling is you have a suite of services. Your microservice, let's say, has like 25 or 40 suite of services, and you want only few services to scale because maybe, let's say, a few set of services are computationally heavy. They take a lot of time to process some input that is coming as a request. And then you want to scale only these part of services, but then rest of the services you just want to leave as is. So that's y-axis scaling. You can scale few set of services in your application suite, and you can leave whatever they are, the rest of the things which are not needed. So this is y-axis scaling. And then if you see, each service is highly maintainable. And then they are loosely coupled from other services. They are not very dependent on each other. And each service is independently deployable. This is a great boon that microservice gives you. You need not bother about other service. You own one service, you make development for that service, and you're going to deploy that. You're going to take care of the maintainability of that. And then another great advantage is small teams can develop services, and this avoids the communication challenges. Like you need not have a very big hierarchy in your organization as well, and you don't need to bother a lot about whom to reach out for what, because ownership lies within the service, within the team. And then yes, these services again communicate in the async or synchronous or queuing fashion, typically HTTP or REST. And we also have seen a few services which would communicate over RPCs and all. So typically, like, but the popular communication styles are going to be through REST, async and sync, and then queuing. Another point is that each service can have its own database, and to have it absolutely decoupled from other services. And it can also have a shared database, like multiple services can talk to one database. And as I mentioned here, it can be decoupled. Again, when I talk about decoupled, each service having its own database, you are going to face with data consistency challenges. You can't run away from that. And today's patterns that we are going to discuss going ahead in the session are highly inclined towards the data consistency related things in the microservice. Yeah. Okay, yeah. So again, going back again, looking from a 30-floor building, your microservice would look something like this. There are 3 services. Currently, this diagram shows you databases that are like isolated. Each service has its own database. Probably there can be dependency on the schemas. There might not be dependency on schema. So there is one possibility that there can be dependency. So we'll discuss all those things going ahead. So the benefits, quickly listing out: highly improved maintainability, better testability. You can have individual testable service. You need not have your test suites running over the whole application like you run in the Monolith. You have your own service component level testing, and then better deployability, autonomous teams, easier for the new folks. So whoever joins into your team, they need not bother about other service. They can first understand well about what's happening in the current service, and then they can slowly start exploring other business side of things. And like when they move from team to team or whatever it is, depending upon the organization style. Yeah, again, faster uptimes, obviously more productivity, and the 2 P's are team rule. Yeah, this is a very interesting thing that the industry generally uses. The 2 P's are team rule. What it means: any team that is owning a particular service, you should be able to feed that team with 2 pizzas. So means the team should be like 8 to 9 folks. Your team should not exceed beyond 8 to 9. That is the ideal team to own a microservice. I mean, it's again obviously debatable, changes according to the business requirements, but that is the ideal thing that we have.
Yeah, Akhil, I think we have a question here.
Yeah.
Which one is better, the separate database for service or separate database schema per service? So that's the question.
Sorry, can you repeat? Is it separate database per service and separate schema per service?
Yes, correct.
Okay, I see this question as 2 different questions. Separate database, I mean, is it like 2 different types of databases? Is it like NoSQL and then SQL? Okay, I assume when you say 2 different databases, like if you are dealing with single type of database, like if it's a NoSQL, then you can have different database tables all hosted in one database. Like, why do we need different databases? Again, if you have a requirement of high availability, maybe you can distribute them. So it's a lot of a business decision that you have to make. And schemas, definitely they are going to be different. each service can have its own schema. Sometimes multiple services can query on the same schema. So it depends on business case. So there is no right or wrong.
I think that answers that question, Akhil. Akhil, I have one question here. So since we are talking about the microservices from monolith to the and architectures inside microservices, so do you feel any? I mean, at any time, like we should use it only fits for the monolith, not the microservices. Are there any situations?
Only fits for monolith if you are a startup, I would say, and you want to hit the market so soon than your competitors, and you have a very small starting team. Go ahead with Microsoft. Go ahead with the monolith. Deploy them. Get the market. Once you grow in your team, in your business, then start re-architecting your platform and move towards a microservice, because microservice will take time, but it will give you fruits going ahead. Monolith is not like that. It gives you instant results. You build it quicker and you deploy it. So it depends again on what is the business problem that you're going to solve. So if you are thinking long term, if you are having a vision of growing in the business, then definitely you should think about microservices, but not immediately going down the line.
Cool.
And, microservices, when you have to take it, you are already a very good established organization. You already have a very good market capture, and you want to now modernize your tech stack. Now you want to catch hold of your existing customers, attract more customers. Then you think about strategizing and moving towards microservices.
Yeah, got it. Akhil, thank you so much.
Yeah. Benefits. So fault isolation, we have the fault isolation because issue in one service is not going to affect any other service. Like you can fix the issues in your own service, but then these things comes with a catch. We are going to again just hold on to these few thoughts that we are getting on the flow. We will discuss about all these going down the line. And again, no long-term commitment to tech stack. Come on, you have a service built in Java tech stack now. You have it running. You are running it very well now. There is a good talk or good hype going towards some functional programming aspects. So you can go and have your new service that is being written in Elixir. It can be written in Golang, and then you can have the functional aspects in that service, like properly functional programming implemented in the new service. So not just tech stack, your whole paradigm of programming can change. You can change from an imperative programming style to functional programming style, and then you can have both of them in your microservice architecture. So that's the kind of leverage that the microservice gives you. Again, as I said, microservice is not all the cakewalk, right? So whatever we had, the problems which were inside the monolith, they got distributed across the architecture around the services now. So you have an additional complexity now, because each service is talking with other service, and then you need to take care of partial failover. So you sent a request to one service and it failed. How are you taking care of the communication? So all these things come into picture. And your request can span over multiple services now. So it's not like you hit an API and it is going to fetch the response from one service and then it is giving you. It's not like that. Your data ownership that you want for your response can be spanned across multiple databases, and then multiple services have to query them. You have to aggregate and then you give them. So this is another complexity that you see here. And then the testing the interaction between the services is difficult. When I said microservice gives you a really good testing ability, I meant it inside the service. So you can have unit tests written inside your service. You can have integration tests written inside your service. But when you want to test the interactions between the service, yes, again, you need to have a different testing strategy for them. I've also included about that in the session today. We'll talk about that, how we are going to test these interactions. And then you need to have a little bit of good coordination among your teams, because typically in a microservice architecture, you'll have upstream systems, you'll have downstream systems which are interacting with each other. They have to be in contract with each other. So we'll talk about all those things. And then obviously, yes, this is going to bring up your costs because you're going to use more computational power. You're going to use more memory consumption because you're going to deploy multiple services. And that's why I said, if you are well-established organization, you have to think about microservices. If you are a startup, start with a monolith. And yes, again, here are the few things that we need to address, right? So when to use microservices architecture? I think we just discussed in one of the questions that was just asked some time back. And how do you decompose these applications to different services? How do you maintain the data consistency that you're going to face? How do you maintain the data consistency? Because this gives you a lot of inconsistency in data. And then how are you going to query the data that is owned by multiple services? So we will be talking about all these things going ahead. So yeah, now we are going to jump into, I think this is till now, it was more like a context setting that I tried to make till now. I hope everyone is on the same platform now. They know basic difference between what monolith is, what microservices is, when to use what, and what are the challenges with each of them. So now we'll start with these things. So any questions till now? Or are we good?
I think we have one. The first one is like if you have any common data, like the user data in service 1 and which is needed by in a service 2 as well. So should we maintain them in the both the databases? Like you said, we can have database per service.
Yes, you can, like that depends upon what each service 1 and service 2 are doing with this user data. Are they dealing with totally different business logics? Because my question back to you, why do you want to have two different services dealing with the same user data? If again, as I said, your services should be loosely coupled, but they have to be cohesive. Cohesive, I mean the functions which are close in their business logic should stay together in one service. So if you ask me, if I have to design a system where two services use the same user data, I would put those two services into one service only and have one database for that.
Yeah, got it. I hope that answered the question. Please upvote if you think your question got answered. I think we have another question. How can we handle DB transaction on common DB between multiple microservices safely?
Yeah, that's a great question. I have a whole section to be discussed about that in the session today. So please hold on to that question. So we will be diving a little deeper, decently deeper into that answer.
Sure. Yeah, cool.
Yeah. Cool. Okay. So now, yeah, decomposition patterns. What I meant by decomposition patterns here is like, let's say you already have a monolith. Now you want to move towards microservices. Like now how we are going to decompose this monolith and how we are going to segregate and how we are going to decide which part of business logic should go into which service. We have a few patterns to decide on that. We'll look at them. So the first is going to be the business capability. So you need to look at what business capability each service should have. And before that, again, let's fall back to our template. What is the context that you have now? A service should be small. The service should be able to be developed by a small team. It should be easily testable, and changes that you're making in any service should not affect other services. It has to be only in that particular service. Like at least you should try to reduce the impact area of your changes to as less services as possible. Ideally, it should be one, but I know when we deal with organization level projects, it would span across, it would impact other services as well. So yeah, it's that that you have to keep in mind. So the question now is, how do you decompose the application into services? And the few factors that you have here, the application must be stable, obviously, and the services must be cohesive. The point which we just discussed, similar functions should stay together in one application. So your service must abide to CCP. So CCP is I don't know how many of you are aware. We call it the common closure principle. I'll just talk about that. And then it should be loosely coupled. Again, the two pizza to wool and minimal dependency on other teams. So the CCP thing, common closure principle, we call it. So for example, this is a practice that we follow when you're designing classes, right? So this like kind of states that in any change, state like the classes that change for same reason should be within the same package. If you're like this, I'm talking at a very code level now, very low level, not the architecture level, the code implementation level at a class level. So if you're making any change for this, and the classes that are going to impact out of this change should be within the same package of your or the same directive, right? So you should kind of use this kind of thinking when you're thinking about designing the services. So whatever business logic impacts other business logic, you should try to keep them in one service. There is another principle that we follow. I don't know, again, we call it SRP, single responsibility principle, coined by our Uncle Bob, Robert C. Martin. That typically states that a class should have only one single reason to change. So again, this, when you apply this to the services, so you should design the services that are cohesive, and you implement a small set of strongly related functions together in one service. So when you think about these two principles, the SRP and the CCP, and when you apply to the architecture level and bring it to the business capability thing, so you should design your services according to your business capability. Suppose your business, that is on the left side of the box here, you have a catalog management, you have a order management, inventory management, and delivery management. So these four things are quite independent to each other, right? So you can have four different services designed, which can take ownership of these four business models. Sorry, business capabilities, right? So what would be the result of this decision that you are going to make? You'll get quite stable architectures, and development teams are cross-functional. So each service ownership lies with a team, and they can interact with other teams, and they are quite autonomous because catalog management is quite a decent isolation from order management, and then so is inventory and the delivery management. So there can be they are obviously very they'll be obviously very autonomous, but definitely there has to be some communication among them. And yes, cohesive and loosely coupled. So again, so what should you consider when you're taking decision on dividing based on the business capability? Your organization structure, as well as a very high level of domain modeling is required. Like the whole team should sit together and they should understand the business very well, so that they can make decisions, and then they segregate this fully. Next, we have subdomain. Again, the same context, same question, same factors that you have. We are going to divide by the subdomain now. And subdomain, this comes from a domain-driven design principle. DDD is quite not in the scope of the current session. So you can read about DDD. In a one-liner, DDD is all about designing your architecture based on the business domains, right? So I'm not going to dig deeper on DDD now. So a very basic classification how you can do about your domains is like you will have a core differentiator, or the most valuable part of your whole application or your whole software. That is going to be the core of your domain or the subdomain. And then you have a lot of supporting domains around it. I mean, these can be, these subdomains are typically, they're outsourced to other teams to develop outside your organization, or they can be developed within your organization as well. And there will be few domains which are quite generic that get spanned across the whole domains. So I get it. It would be a little overwhelming to talk about the DDD here, but this is one pattern. Maybe you can take this as a knowledge. You can go ahead and read about this. I'm not diving a little more deeper into the subdomain concepts and all. So I just gave a few examples here when you think about subdomains. Again, product catalog, insights, like the business insights, and the order management and inventory, a few subdomains that you can think of. And if you look at a business subdomains, how they would look like. So you have a order management subdomain, inventory service, delivery service, catalog management. If you take a closer look. Business capability and subdomain, they look very similar to each other. That's why there are alternative patterns that you can pick. That's why you see the dotted arrow there. You can pick the alternatives. Like you can, like both of them have closely related trade-offs and advantages. So it's up to the leadership teams or the development teams to take decision on these things. Again, these things, subdomain pattern also gives you the same results and same concerns of what the business capability has given you. Yeah, next we have self-contained service pattern, like another decomposition pattern that you can think of. This is again independent pattern, not related to business capability or subdomain. So the context you have here is like, let's say you are going to build a ticket booking application now. And the client's expected time is going to be less than 600 milliseconds. You should be really quick for this, right? And then ticket booking process is scattered across multiple services, as like the diagram shows here. When a client makes a post call to the booking service, it is going to first go and fetch data from the customer service, and then probably it makes another call to another service to get payment or credit related information to see if the current customer has any credit in his account or any payback points in his account which can be used. And then it makes, I just gave the dots here, like it can be any number of services. I'm just showing it with dots here. So one request came from the client and you are making multiple requests across different services. So what's happening here? You are blocking the request that is coming from the client, right? Until you get responses from all the downstream services that you're making calls, you can't reply back to the client. So you're unnecessarily blocking the client. So obviously, potentially high possibility that your response time will be much greater than 600 milliseconds. So another big concern is, what if one of these collaborating services are down, they are not available? How are you going to deal with this? So yeah, the factors again, when you're thinking about self-contained services, so it should distribute, the microservice architecture often distributes the responsibility of handling the request among the multiple services. High availability with low response time. This is what, I mean, one predominant factor we need to consider, because we are thinking of response time less than 600 milliseconds. The availability of the operation is equal to the service availability multiplied by the number of synchronous collaborating services you have. Like you made one call, so how many calls you're making? Like you get this basic math, right? So this is going to be the like formula which will decide your availability. One service goes down, you are blocked for that request. And a service should be able to retry for the failed collaborator. So let's say your consumer service has failed, like you should be able to retry it. So yeah, and then it's up to you how in what kind of situations we might end up, like leaving to you. You can think of the different scenarios that we can end up. So now with this type of implementation, we have that problem, right? So when you implement the self-contained service, so you design a service so that it can respond to the synchronous request without waiting for the response time of any other service. So again, if you don't confuse here, this was a traditional implementation that I was showing. This diagram is not related to the self-contained service. This diagram is related to self-contained service. I just wanted to set the context here. So this diagram is a self-contained service. So what did the booking service do? As soon as the client, it got a request from the client, it has shooted out the response immediately, and it has sent the request to the customer service. This communication is going in a, I mean, it's not blocking the request that is coming in. If it basically it eliminates all the synchronous communication between your services, right? And then you can use something like CQRS or Saga patterns to book the service here. I mean, don't get worried. I mean, don't worry about CQRS and Saga patterns. We have it in the session. We are going to deal with that now in some time. Order validation can happen asynchronously, right? Your order booking the booking service has already made the call to the customer service, and then that validation can happen asynchronously. You need not wait for it. And if it fails, have another kind of a intimation that you can send to the client, not immediately, but in a different way. So your whole thinking, your whole solutioning will change when you think about asynchronous communication. So, I mean, with this current setup, you can't immediately tell the client that your booking has failed. Probably client might have to continuously hit the get endpoint of the booking service to see the booking has been successful or not. So this is one concern now here when you are sticking to self-contained services. So we'll deal with how we are going to. Yeah, I have a raised hand here.
Yes, Akhil, we have a couple of questions here. Would you like to answer at the end? Or
I think let's finish off this section and then I'll take those questions.
yeah, sure, please.
So yeah, these you get it right. Like client has to make maybe a few get calls to see if the booking was successful. So typically, this is how it would get handled if you are going ahead with self-contained services. You're going to use some message channel queues or event channel queues, and then you're going to shoot out the events to the other services, which we saw the customer service here and the other services here, and they process them. They process the request asynchronously in the backend. So yes, again, we'll deal with CQRS and Saga patterns going ahead here. So what are the ways of implementing self-contained services? As I just wrote down here, implement the needed functionality as a service module rather than a separate service. So you can have the one service module implemented within the service and use CQRS or Saga patterns to replicate the data across multiple services. Yeah, and then the result of this decision that you made for decomposition is like you have improved availability for the response time now, but it has improved, increased cost and complexity because you're using CQRS here. And then sagas are very complex to deal with. We'll get to know about sagas because when you are going to use sagas, you have an additional complexity here. And then the APIs are not very straightforward. And you have service due to the functionality being implemented in service instead of separate service, like, right? You have a large service, probably you will end up implementing in one service in as a one deployment than having a segregated deployments. And when you think of one service per team as a decomposition pattern of your monolith, so you'll have a really the context is you need to have a good high performance team, the two pizza team rule, and then the Conway's law. I don't know how many of you are again aware of Conway's law. Conway's law states that the kind of architectural mindset or the architectural solutioning that you're going to make, the architectural design that you're going to make, is highly influenced by the hierarchy you have in your organization. So how much of the hierarchy you have in your organization, you will tend to have that kind of design in your architecture because you are consciously, subconsciously biased towards the communication hierarchy that you have, and you try to put that into your architecture because you try to replicate that kind of dependency on the teams when you're designing. So that's what Conway's law summary is about. And organizing an organization consisting of loosely coupled teams, they need loosely coupled architecture. As I said, again, this is a lot overlaps with Conway's law. So yeah, question here: what is the relation between the teams and the services? Again, the few factors that you need to consider: two pizza team rule, 5 to 9 people in a team. The team should be autonomous. Size and the complexity, the code base of one team should not go beyond their cognitive capacity. And then you should have fine-grained service decomposition improvements, the proper maintainability, testability, and deployability, and then fine-grained service decomposition adds a very good complexity to your whole architecture. So if you take a look at visually how this would look like, so if you see the service one has 2 modules that is being owned by one team here, and there is another team that is owning service B, and they communicate with each other. And then typically, definitely we see teams going beyond and owning multiple services. This shouldn't happen ideally, but I mean, there will be countless reasons why you might end up one team owning multiple services, but that's absolutely fine because nothing is ideal when you're going to implement anything basically. Yeah. So the result is you have autonomous teams, a very minimal coordination among the teams, loosely coupled. So the drawbacks of this is going to be all your teams that are going to develop these services, they need not be aligned towards end user features. And relatively, they might have higher collaboration. They might require higher collaboration among them. So yeah, questions now.
Yes, Akhil. Let me read it for you. So it's actually a question to the answer that we had it earlier. So it's from Aditya Jaroli. The question is, let's say if we have two services, service one and service two, and can we have a API call to service one to fetch the data if we need if we need the same data for both the services?
Can you please?
Otherwise, if you are merging two services again, it's going towards the monolith again, right? Like we said earlier, why do we need a service, two services for the two databases?
Yeah. So if you are merging two services, it doesn't mean that you're going towards monolith, because your microservices can have like 20, 40 services. Out of these 40 services, merging two services doesn't push you towards monolith. It is a cognitive decision that you make to make optimal utilization of the resources. Because the kind of mindset behind monolith or microservice is not just about merging a few code bases together or putting few code bases together. It is much bigger. It is about the deployments. It is about the maintainability and testability. So merging two services out of like a suite of 14 or 20, 25 services, it is not being pushed towards monolith. It is still a microservice architecture.
Okay, cool. Bindu, I see you raised your hand. Can you post your question in the Q&A section, please? Yeah, I hope Aditya, let me allow you to talk. Yes, Aditya.
Hello. Hi. Can you hear me?
Yes.
Yes.
Yeah. So this was more towards I wanted to learn that. So when users data is there, right? The specific question was, let's say service one has a users data in DB. Service two also needs the users data. It could be to verify whether user is correct or not, or to put the user ID into DB. For that, a simple API call from service two to service one would be enough, right? Why do I need to merge these two microservices? Because when I designed them, they have a separate concerns. That's where I created two separate microservices. Yes, data could be needed. If we take an example of ordering app or any e-commerce app, I need orders for the deliveries, for inventory, or for anything for that matter. I can't merge these microservices because I need orders data everywhere. Shouldn't an API call be the way that whatever service needs orders data, simply calling the API, getting the data which is required and processing further?
Yes, that absolutely makes sense to have an API call to get the data.
Okay.
But I think the way I understood the question was, can we have the users data split across two databases owned by two different services?
Yeah, but the users data is also something kind of platform handles it, right? For authentication or something.
Yes.
Why would two DBs should handle that? It should be a concern of one service
Yes.
which owns the entire platform and replies via the APIs.
Yes, I agree with that. You shouldn't have same data in two different databases owned by two different services. If you're because you will have two different sources of truths. Like,
True.
I don't know if I'm getting your question wrong, but I agree to the point you said.
Okay. Okay. It could be I understood the question wrong, but yeah, whoever asked, maybe this discussion might have helped him.
Yeah.
Thank you.
Yeah. Thanks, Aditya. Yes, Akhil, I think we have one more. How can we handle DB transaction on a common database between multiple microservices safely?
Yes, we are going to discuss about that soon.
Cool. Yeah, please go ahead.
Yeah. So now we are going to deal with the data patterns now. We talked about decomposition. We talked how you decompose and all. And now the data patterns. So again, here, we have two patterns that you can have. One is a shared database, another is a database per service. I think in the interest of time, I'll go a little faster because we have a lot of things to be covered. So the context here you have is you're building a service booking application, and most services need to persist some kind of data in their own DBs. Examples, as I mentioned here, service booking stores booking related information, and customer service stores customer related information. The question for you is like, what is the database architecture that you are going to choose for the application? The fact is, again, a service should be loosely coupled and independent. Business transactions must enforce rules that might span across multiple services. So one call that you're making might have data split across multiple DBs owned by multiple services. And then some business transactions need the query to be the data that is owned by other services. So database should be able to scale, and different services have different data storage. One can be in relational databases. One service can be having it's dealing with an NoSQL. It can be anything. So these are the factors that you need to think about. Now, when you're going with a shared database, so you have a single database for all your application, for the whole service suites that you have in your application. So each service can freely access data owned by the whole platform with local asset transactions. Result is that your team is quite familiar with asset transactions, and single database is very simple to operate. And then the concerns that you're going to have, the development type coupling. So you might, when multiple services are owned by multiple teams, they might have requirements to change the schema, and then other team might not need the schema change. So this creates a lot of dependency on each other, and this slows down the development process. And you have now the runtime coupling coming in. So whenever the requests are made, one service will hold the lock on the database because that is shared, and another service has to wait for the lock to be released to access the data and then get the outcome out of it. So, and as I discussed, single database might not fulfill all your requirements across different types of data that you want to hold. And what if the DB goes down? Nothing, like it's a catastrophe. So next, the database per service. So like as it explains, you have one database for each. This will isolate the microservices properly, and they're totally distributed now, highly loosely decoupled and well isolated. And then the things that you want to worry about. So your queries will now span across services, across multiple databases, and distributed transactions are best avoided because I don't know how many of you know the CAP theorem. It's a really, really interesting theorem you need to read about. Your consistency, your availability, and the partition tolerance, they can never, all three of them can never go together. You have to compromise on at least one thing. Either you have to give up consistency, or you have to give up availability or partition tolerance. I'm not diving deeper. This is a really good theorem to read about. Go back and maybe it's a kind of a homework that you can do it. Read about them, and then you have, when you're dealing with multiple types of databases, NoSQL or SQL, you can imagine the complexity you need to deal with, right? So yeah, these two are things when you talk about shared databases and database per service. Now, with the database per service, we have another branch coming out. We have API compositions, and then we have CQRs. So now the context is you're using the microservices. You have database per service pattern, and your business requirement is no longer straightforward queries. Your query should span across services. So the question is, how do you implement queries that are in this type of architecture that get spanned across multiple things? So you need to have an API composer. So you invoke the service that own that data and perform in-memory joins, and you get back the result. So if you visually take a look at it, whatever request that comes to your platform, it will first hit the API composer. Your API composer will go ahead and make the calls to respective services that own the specific data. It will join the data, and it will process the data a little for you, and it will give back the response. So you have only one endpoint to reach to get the data, but internally it is calling multiple services. And then what concerns do you have here? So what if your data set is huge? What if your joins take a lot of time? You go out of memory if your data set is huge, that is coming from service A, and you're doing an in-memory join that you're doing in the API Composer. And one advantage I can say about API Composer is you can take care of paginations inside the composer itself for the pagination requests that are coming from the clients. But the bigger concern is the big data set, you're doing in-memory joins. So yeah, that is the trade-off you have with API Composer. So the next kind of pattern that you want to that we would see is CQRS pattern, where same context you have microservice that DB per service, and your querying is not quite straightforward. The question is, how do you implement a query that retrieves data from multiple services in a microservice architecture? Now, if you see here what CQRS is doing here, the model that you write is different from the model that you read here. So CQRS separates reads and writes into different models. You're going to use commands to update the data, and you're going to use the queries to read the data. So commands are typically, they are task-based here rather than data-centric. It's like you send it as a task, and it updates the right model that you have. And the big power that you can give to CQRS is making all these things asynchronous. And your queries should never ever update or touch the data in the database. They should only query and read them. Like, that's an absolute concern that you have to take care. Your query should never modify the database. And then, yeah, if you see, there is a replication happening between your write DB and the read DB. So you can use events, you can use queues or anything. Whenever an update happens to write database, you can use events, and then you can replicate that in the database, in the read database. And you can, the greatest advantage that CQRS gives you is you can fine tune your schema in read database to have high read throughput, and you can fine tune your write database to have a high write throughput. So you can't have this with a traditional service traditional architecture, right? So if you're not going with CQRS, if you are using same database for reads and writes, what if lot of parallel concurrent users are trying to query your data? Like it gets overwhelmed, and you can have proper materialized views that you can store in database, which can give you quick queryable results. So again, the result of this is it gives you good denormalized views, and it improves separation of concerns. And this is absolutely necessary for an event source architecture. And the potential things that you need to take care of, it's a code duplication probably you might have, because you need to maintain different models, and probably the code duplication can have duplicate across these models. And then your views are going to be eventually consistent. Whatever goes into the write DB, that doesn't get reflected exactly at the same moment in the read DB. It would take some time to reflect its eventual consistency. Now we are going to talk about the saga pattern here. So the context here is, how do you transact your query across multiple services? So this saga pattern is all about transactional querying that you wanted to. So a couple of questions have already come out about transactions. So you can't use two-phase commit for this. So what Saga does is, you have a set of services. So each transaction is a local transaction. So your first service, when it gets a request, it makes a local transaction. Once it is atomically successful, only then it sends the event to the second service, and then it forwards the event to the third service. And then as a whole, this transaction should be successful. If anything in this transaction fails, there should be a compensating request that should go into a Saga, which will revert all those successful local transactions that has happened. So you get it right, like each transaction is atomically successful in local and then passed on to the next in the form of an event. Again, there are two different implementations for your Saga. One is a choreography style, where you get the HTTP request to your service, and then you send out two different requests you see the green path, the 1 and 2 in the green and then 1 and 2 in the red. So whenever you send a request order created event to this, if it is successful, if the credit service is properly able to process it, it will commit a local transaction, and this will send it out to the next service. If it has failed, it will send an event back to the order service saying that the event which I just received for order creation has failed. So you need to send me a compensating event which will revert the transaction I have made. So yeah, again, this is quite a simple workflow. This doesn't have any single point of failure. But the issues with this is it gets quite confusing. Imagine having so many services which are talking in this way, and testing is quite difficult, and potentially there can be cyclic dependencies. So one mitigation that you can do is you can have an orchestrator behind this, and your orchestrator can take care of things instead of your like when should the success event go, when should the compensating event go, and all. Your orchestrator can take care of this. But again, this comes with a design complexity, and there is a single point of failure for this. If your orchestrator goes down, everything is gone. So you have to take care of this here. So your orchestrator should be highly available. Any questions here? I see a few things in Q&A.
Yes, Akhil, couple of. So I think how can we handle DB transaction on a common database between multiple services is covered as part of this discussion, right? Yeah. And there requires much more deployment in Monolith. How do we overcome this? Yeah, I hope it is like in microservices, we have multiple deployments in Monolith, multiple deployments. Whereas in Monolith, we'll go with a single deployment. How do we overcome this? I think that's the question.
Yeah, I think I have already talked about this. You have a single deployment, but at what cost are you having that single deployment? Your deployment time is higher. For like, how frequently are you able to do this single deployment? If you're dealing with a monolith, I'm sure you're not very confident. You have to take care of a lot of things. Because I have seen teams which would spend the whole Friday night fixing the deployment issues. But with microservices, you can have very small deployments. I have seen teams where they deploy their service once in a sprint. I've seen teams where they deploy every commit that they make to the master directly goes to the production. So look at the deployment frequency that you have and the deployment capability that you're getting with the microservices. Is it one time with a long gap, many functionalities going together, or multiple frequent deployments, small things, so that you don't have breakdowns in between?
Yeah, I hope that answers the question, because most deployments means more quality of the deployment that we can get. Next question: how to cope up with event schema changes? Say over 1 year, CQRS events undergone multiple changes.
Typically, that depends upon the business case. Why do you want to bother about the schema change that is happening to the event? If your event is changing, that means your logical processing has changed, right? Why do you want to process events that have occurred 1 year back from now? Are you maintaining an event store in your team or in your software, and you want to revisit the events? If you are doing that, I would say it's a very bad practice. You should. I don't know why someone wants to go back to the events that have occurred 1 year back. So event is changing, that means your business requirement has changed.
Okay, so I do think it has, we should be very clear about the business requirements before getting it started. Let's go to the next question. CQRS has higher cost to maintain multiple DBs. Also, how is it solving large joins between multiple microservices, because each microservice still has their own DB? Or are we restructuring all DBs into one read DB?
If you see the CQRS that branched out on database per service. So it is one pattern that you can have under database per service. And CQRS is about maintaining different models to get different performances on your writes and reads. yes, it is still a database per service, but a different business requirement. You need either you need high write throughput or you need either high read throughput. And you can have materialized views for the views.
Okay, cool, cool. I hope that answered your question, Navin Chandra. So, in a next question, in a transaction flow, if there is a failure at second level of transaction, with this saga flow, this whole flow increases stacked. How to handle the tact?
Yes, if it fails, there has to be a compensating event that has to come into your platform. Something has to trigger a compensating event so that gets rolled back. Whatever, suppose local transaction 1 was successful, 2 failed. So either your orchestrator should send out a compensating event so that the successful local transaction that happened in the service 1 will get rolled back. It's a very complex pattern that I would definitely agree on that. So you have to be very careful when you want to go ahead with saga pattern.
Okay. Again, what about the service response and response time?
Is it with respect to saga pattern?
Yes, correct.
Yeah, saga pattern is asynchronous. So, for example, the order service which has got the request would probably send an event to the orchestrator, and it would reply something to the request that has to the client that has made the request. So, if you think the request that is coming to the order service, if it is coming from a end user who is doing the request from their mobile screen or browser screen, definitely your saga pattern should not come there. Your saga pattern should come somewhere between the services to maintain the data consistency. This shouldn't be a user-facing pattern, because this is more about asynchronous communication and data consistency, not the request response thing.
Okay, okay, got it. Okay, I hope that answered your question. Yeah, I see a thumbs up. Yes, Akhil, please go ahead.
Yeah, cool. So now what we are seeing is aggregate pattern here. Let's say your microservice has like 40 or 50 services, and each service is holding its own domain. So one service has outpatient coverage, one has dental coverage, one has vision coverage, and all. So there is a person alpha. Now, if you want to know what all benefits this person alpha has, are you going to query all 140 services here? Are you going to make 140 or 40 API calls here? No, right? So what you can do is you can aggregate data that is coming into these different services, and you can have an aggregate of all these things in one aggregator. So whenever a data update happens to either one service here, let's say dental coverage got updated with some request, you have to immediately send a queue event to the queue, and you have to update that aggregator with this data that got updated, so that whenever you make a call to get some aggregated information, you make only one API call to this aggregator, not 40 different calls to different services. So again, it depends upon what type of aggregations you need, what type of aggregations you want to store in your application. So it is a lot of business decisions that you have to make. Let's say, how do you take care of aggregations? This is more again from a DDD domain-driven design concept. So your aggregation should it is basically a cluster of domain objects that can be treated as a single unit. So if you can aggregate what all coverages does a person have and keep it as one materialized view in your aggregator. But if you want to keep an aggregation which would think about the cost that you're paying for different things, and then different timelines of your coverages into one aggregation, that wouldn't make sense. So it's very important how you define your aggregations and how you separate those aggregations and store in your aggregated service. There is one pattern that it's quite famous, where we can use the aggregated service, and you can store aggregated domain models or business models. So again, now domain event, this is branching out from CQRS now. So here I'm listing out two lists. What do you exactly see the difference between two lists? The first list is about a person is adding product to the cart. Another is he's updating, he or she is updating the new address, and then a person is making the payment. Next, you have cache hits, cache miss, and requests to the servers are made in response to the server services. What do you see are the difference between two lists? One list is absolutely about the domain. One list is totally technical. When you go to a business person in your team, your product owner or anything, and if you say to them that the cache hit has missed or the hit has occurred, why would they bother about it? They would bother if the product got added to the cart or not, right? So these are different types of domains, events that you can think about. Now, when you are thinking about domain events and when you have two different aggregates, what you're sending from one aggregate to another aggregate should be a domain event. It shouldn't be a technical event. Technical event should be handled in a different way. Domain event should be handled in a different way. So aggregates now, each aggregate. So this might answer a couple of questions that we got earlier. Now the inventory aggregate need not look into the database of buyer aggregate, and buyer aggregate need not look into the database of inventory aggregate. Buyer aggregate got some request, shoot the event to the inventory aggregate, and buyer aggregate is done. It doesn't bother whatever had happened to that. And it's up to the inventory aggregate to take care of reading that event, domain event that came in, having proper failure handling scenarios. If it has failed to process that, like these days the queues are quite reliable. Something like Kafka or SQS, they come with acknowledgement, where you can give an acknowledgement to them whether your processing was successful. So your domain event, you need not, you just send it and forget it. It stays in the queue until it is successfully processed by the inventory aggregate. So this way you can avoid handling two different databases to maintain your similar data. And you like, suppose you need not run cron jobs across having data consistency across different databases. You just fire an event and forget it. It's up to the inventory aggregate to take care of it. Again, the precondition is the messaging queue that you're choosing, the queuing platform that you're choosing should be able to accommodate that error handling possibilities. And yes, the great result of this is it doesn't have locks on your databases. And then this is the event sourcing platform that we need, that we can think about. So again, this ties back to the question one of the person have asked: what if you want to go back and see the events that has occurred 1 year down the line? What if the event schema has changed? So event sourcing pattern is all about the events. You don't, instead of just the current state, you only rely on the events that has happened. You don't want to revisit the event that has happened sometime down the line. And you don't, if you want, you can store the events for a limited period of time in the event store and have a processing. That's absolutely fine. But I personally wouldn't recommend this pattern to anyone, because this doesn't give you traceability at all. You are sending events into your platform, and one of your event failed. You can't go back now into the event queues, and you can't see what event has gone wrong. There is no traceability. You just process events as and when they come, and you go ahead with that. So it is a very interesting, technically very implementation wise and technically very interesting pattern, but not a great pattern when you want to have a high reliability of the business things. Okay, yeah, these are more about the data consistency patterns I want to discuss about. If we don't have any questions, I'll straight away jump into the testing patterns. Any questions, or can I go ahead with the testing?
Yes, Akhil, no questions as of now. Please go ahead.
Yeah. So testing patterns now, you have multiple tests that you can have, right? You can have a component level test, you can have an integration test, and you can have contracts test. So when it's component level test, you make sure that your component and the business logic that sits inside your component is perfect. You need not bother about what is happening outside your service area or your service logic, right? So but the drawbacks of this is the scope of this testing is very limited, but it is very fast. Component level testing or integration testing, they're comparatively faster, and when you run them in your pipelines, They give you decent results. You don't hold your pipeline for a long time. Now, what happens if your microservices are like this? I don't know, like Death Star is one analogy again from the Star Wars franchise, where Death Stars are used to destroy the planets with a laser beam. So we have a dark Vader here. So Amazon and Netflix have their microservices like this. Each dot you see here is a service, and this whole is a platform. Look at the number of services they are dealing with. So you did your component level testing, and your pipeline is green. There is a provider, I mean the upstream service. Consumer is a downstream service. So provider has a first schema. In the JSON contract, the name is a Batman and the role is a businessman. So it's perfectly fine. And then there was a change in the JSON contract they had. Now the roles is an array. Like Batman is businessman along with the detective. Their pipeline is still green because they change their component level test according to this. But when you deploy this, your consumer pipelines will fail. All your downstream system pipelines will fail. What is happening here? Because the consumer service is still expecting the responses to be coming in the format of role is just a key value pair, not an array. So how do you mitigate these things? You need to have contract tests in your application, in your microservice. What contract test is? You are an owner of, your team is an owner of a service. You have a contract. Like this is a contract. This is a JSON I'm going to send out. So you publish this contract and you store it in a broker. Pact is one broker. A broker is just think it as a platform which will take two contracts, one from the provider, one from the service, and then it verifies and then tells you if the contract is intact or it has broken. So the publisher will publish their contract, the consumer will publish their contract, your broker will compare them, and then let your pipelines be green or go red. So imagine microservices of this scale not having a contract test in place, and how would their platform be? It wouldn't sustain even a single second. So your contract testing is a must and should when you are thinking of microservices architecture. Again, there are different types of contract testing. I'm not diving deeper into this. I have a separate talk that I gave on contract test. Maybe I can share the link after the talk, specifically on the contract testing. So there are different types: integration contract testing, consumer side contract testing, and the consumer-driven contract testing. Consumer-driven is the consumer will tell you what contract I want, and the provider should abide to that contract. Yeah, and then because of this, you can find the development. You can find the bugs in your development only. You need not wait till you deploy the service and see that the contract has broken. You can find it in your development only by running the contract test. Deployments are like faster, safer, and more often you can do them. You can have offline API stubs to have the contract test. I think in the interest of time, I'm going to skip this slide. I'm very sorry for that. This talks about different UI patterns. This is a very light touch up that I did. I'm going to skip this. So let's discuss about the application infrastructure patterns. So how would you take care of the security of your microservice? So one is a TLS between the service. You need to have SSL communication established within your services. All the communication has to happen through the properly SSL, like with proper SSL certificate in place. There can also be scenarios where I was also involved where you can do a TLS termination, but you need to be in a private cloud for that. Suppose a request came to your service, and from that service, whatever request that you send to other services, they can be like the basic HTTP. They need not be HTTPS. And the precondition is these two services should be inside a private subnet, not in a public subnet. And then you can do IP whitelistings. You can allow requests coming in only from a couple of IPs, but not all. And then you can have access tokens implemented. I think most of you might be aware of access tokens, the JWT tokens or JOT tokens, they call. There are multiple types of tokens that we use. If you're not aware, it's a really good read. Access tokens also have some drawbacks. That's again a different, totally different discussion altogether. But this is one security practice that we can have. And the observability of near microservice, with great power, comes great responsibility, right? So when you are having such a great power of microservice architecture, you need to be responsible. You need to have proper audit loggings in your place, proper application metrics. You need to have distributed tracing. Distributed tracing is like whenever an event enters into your platform, and to the moment it exits your platform, you should be able to trace it. So whenever your request enters your platform, you have to associate a uniquely identifiable trace ID with that. And with this trace ID, you should be able to track it until it ends up into the database, or it ends up getting processed by some downstream systems. And then obviously you need to have health check APIs, because once the health check goes down, the service has to be spawned together. You need not bother about this. Most of the cloud providers like AWS or GCP or whatever you're deploying in, or Kubernetes or anything, they will take care of respawning your service. They will orchestrate that once they see the health check is failing for a particular service. And then your exception tracking and the log aggregation, all your logs that are emitted by all your services in your microservice architecture should be aggregated at one place, and you should be able to see them at one place to get proper insights of what's happening inside your architecture. And you should be able to log the deployments and the changes that are happening to the deployments as well. This is all you need to consider when you're thinking about microservices. From the observability stand. And cross-cutting concerns, possibly when you're developing microservices, you might end up having similar kind of things spanned across multiple services, like validating the access tokens and logging, distributed tracing, and all. So if you start implementing everything every time for each service that you're developing, you might end up spending 2 or 3 days just to set up these things, because these things are the common things that you want in every single service, right? So you can create a chassis kind of a thing for your application for a service. So this chassis or a service template is a skeleton structure, which is a buildable thing, maybe, and few libraries and few frameworks configured. So it's like a very basic image. You take this code base and you start implementing your business logic on this small code base. So it actually boosts a lot of productivity for the teams when you're implementing multiple services. You just take them, start working on them, because all the basic things that you need here are taken care in those chassis or service templates. And externalized configuration is, instead of you putting few configurations inside a service, you put them outside of the service, and your service will pull them the configurations whenever in the runtime when they get spawned up. Yes, any doubts? I see 2 questions on the Q&A.
Yes, Akhil, let me read them for you. Do we also trace CQRS events using any observability tools?
I'm sorry, I didn't get that question. Do you also?
Tracing CQRS events.
Yes, you can trace, right? CQRS is a data consistency pattern, but this distributed tracing has to happen in every single part of your platform or application. So your architecture pattern or your microservice of pattern is not a deciding factor whether to opt for a distributed tracing or not.
Okay.
So when your command comes into your CQRS, you associate a trace ID with the data model that you are going to write, and save the trace ID into your write model. Replicate that in your read model as well. And whenever you query it, you can still have the trace ID in your query. So you write from your request entering the CQRS, it will still end up in your query. I mean, if you're fetching that trace ID in your query or not, that's a different matter, but you can log it and trace it in your log aggregations.
Okay. So, I mean, using trace ID, we can trace it, right?
Yes.
Okay. So what is the use case of chassis?
Chassis is, it gives you productivity in your development. As I said, suppose you have already created service 1. In your service, you have already taken care of security things, TLS things, network whitelisting kind of a configuration. You already taken care of all these distributed tracing things. You have configured your traceability. You have kept the libraries that are required for logging, the log4j or Lombok, log4j or log back or whatever it is. Why do you want to repeat that when you're creating service 2? Create a chassis kind of a thing. Take this chassis, and now you are bothered only about the business logic. You need not take care of all these things again. Why do you want to repeat that? Put them into a chassis. Commit your chassis in a separate repo and reuse this chassis in all the new services that you're going to build.
So like a library, Akhil, like a library.
It can be, I wouldn't call it a library. I would call it a code base with few libraries and frameworks configured together in one code base, a small code base. It doesn't give any business sense. It gives a technical sense. It is ready to use it. You can take it up and you can start putting business logic into that.
Okay. Okay. Got it. I think we have another question. If my services are in private subnet and only gateway is exposed to outer world, then validating token only once in gateway would be enough? Or
Yes.
should I validate the token in every service? Yeah.
If it is in a private subnet, I would still recommend you have to validate your access tokens, because access tokens doesn't is not just about the security aspect. It also deals with the roles. Suppose one service should not get access to one type of data that is exposed by a service. So you can have roles defined in your access tokens. Suppose one service can have a role which will give access to the user's personal information, and another service should not have that authorization. So your access tokens can have these roles. So the service which is taking this request, it will see if this request coming from this particular service, is it authorized to access this data based on that role, and it will give the response. Else it will deny that request, saying you're not authorized for this. So yes, you need to have access tokens, but again, it depends on the business case to business case. If you're not dealing with any crucial kind of a data, and if you're okay to have all the data being accessed by all the services, yes, you can give up on the access tokens, but it has to be inside a private subnet.
Okay. So Aditi Chirul again. So authorization in every service and token validation only in gateway, would that work?
Sorry, can you please repeat? Authorization only in the
Authorization in every service and token validation is only in gateway. Would that work?
I think this is very much inclined to be almost the same as the question that you just asked, right?
Okay.
Your token authorization can happen at the gateway. It can also be done at the service level. Just that the kind of tokens you receive at the API gateway level, it might be a public token coming from the thin client like the browser or the mobile application, but the tokens that you're getting inside your private subnet are from other services. Like that's for the machine-to-machine communication.
Okay, cool. Aditya, that I hope that answered your question. Yeah, just give a thumbs up. Yeah, cool. Folks, feel free to ask any questions if you have any. Yeah, I think Akhil, we are good at now.
Yeah, cool. So we'll take a look at the transaction messaging. A couple of questions already come up. So what is this? So these are again coming concerns that are coming from the sagas and the event sourcing. How do you do transaction of the? How do you make sure the transaction is reliable? That you made a proper logical atomic commit into your database, and then only you are sending out the event to other servers. So also this also has concerns about the type of order of the events that are coming. Suppose transaction T1 has come first, transaction T2 has come next. So your even event that is associated with T1 should be happening ahead than E2. E2 should not go before E1 goes to the next service. So this is what the transaction messaging is all about. So we can use something called as transactional outbox for this. So what you're going to do, whenever a order service makes a commit, makes an atomic update to an order table, it will also write that commit or update to an outbox table that is present within your database. And you have a message relay that can read from your outbox table and then sends it to the message broker. So the writing that is happening to the order table and the outbox table, that is transaction. It will happen either both together or none together. It is never a case like you update the table, but you miss to update the outbox. It's not like that. It has to be a transaction for both. And only then the relay will read it and you can maintain the order for them. Again, there are two different transactions that you can make out of this. One is the transaction log tailing, and one is a polling publisher. The log tailing is, again, you tail the logs of the database that are coming in whenever these commits happen. You rely on those logs, but the catch here is that these logs are only emitted by few databases, just like the MySQL or Postgres or DynamoDB streams from the AWS. It's not very easy to handle the duplicates publishing that is happening. And the safer bet is on the polling publisher, where your message relay will poll the outbox table, and it will take whenever it needs, and it will send it to and it will send events to the next next downstream services. So again, not all SQLs are supported by this. It's again not very easy to handle the order here as well. Yep. I think we have already overshot by 5 minutes. I think that the session I've planned, few things that I've planned will take probably 10 more minutes. Is that okay for everyone to go ahead, or what do you feel?
Yeah, someone raised a hand. Let me make them unmute. Yes, Sunil.
Hello, can you hear me?
Yes.
Yeah, the question is regarding general, more about that, debugging. So when you have this kind of services, when you have a few services, it's okay. But when you have multiple, you have hundreds and thousands of services, and you have aggregation of data and things like that. Is there some sort of some correlation ID or something which you need for every message, so that you'll be able to debug these the transactions using some distributed tracing?
Yes.
Okay.
Yes, that falls under the observability aspect of your microservice. So the distributed tracing, as I said, any request that enters your platform should be tagged with a unique trace ID. Again, the catch here is probably the service that is owned by one team can have a different trace ID, and when that event ends up into the service that you own, it can have a different trace ID. So you need to be careful about how you are associating these two trace IDs. But if you are going with this type of change of trace IDs happening between service to service, definitely it's an anti-pattern. So any event that is emitted from one service, the event, the trace ID that is coming along with this event has to be persisted across the downstream services. Only then you can get absolutely good visibility of what's happening to this event, and only then you can debug. You can debug that with the log aggregation, because all the services are emitting the logs, and you aggregate these logs and put it into one platform. This can be something like a CloudWatch, or any log aggregation like Splunk or anything.
Yeah, cool. Sunil, do you still have anything to ask?
No, thank you.
Yeah, cool.
Thank you, Sunil.
Yes, Akhil. I think we can bear for a few more minutes. Yeah, please go on. Yeah.
Cool, thank you. So the communication style again, you have the Saga and domain events that we discussed some time ago. So what type of communication that can you use? You can go with messaging. You can go with this domain-specific communication style, and you can have a remote procedure invocations happening. So when it is messaging that you need to that you're going to implement, it can be asynchronous communication over the messaging channels. Like messaging channels can be SQS, Kafka, or any queuing channels, RabbitMQ, or anything. So there are several styles again in the messaging in this communication style. It can be a request response. It can be just notifications, async responses, pub sub models, and then pub sub asynchronous responses. The result is the downstream system or the consumer of your event is quite decoupled. It need not bother about what schema you are dealing in your upstream system. I just bothers about the message I get from my upstream system. I don't bother what schema you're dealing with, how you're evolving your schema. I don't bother. I just want the message from you, and I will process it however I want. And if I'm failing to process your message, I will have my own acknowledgements to the queue to which you are publishing. And this queue should be able to persist the event so that you can process it again and then have the proper error handling in place. So yes, again, this supports many different types of messaging styles, as we discussed in the solution there. Again, things that you need to take care about the complexity this brings along with the message brokers that you're going to implement. And then you can go ahead with domain-specific communications where you can have SMTP protocols for emails and RTMP for real-time media processing if you're streaming data and media and all. And remote procedure invocations you can have, like where you can use REST, gRPCs, or Thrift or anything. But I'm not a very big fan of RPC because it creates a tight coupling to the consumers that are going to make a call to the upstream. You need to stick to the RPC. I mean, if your downstream systems are using a different protocol like HTTPS or REST or anything, but you are forced to use remote procedure calls for your upstream systems. But unfortunately, most of the cloud providers, they rely on gRPC and all, but it comes with many great advantages because it will restrict the client to make a request in a very specific way, and that will not give a lot of configuration into the hands of clients so that they don't end up making a lot of mistakes while making this call, and they're quite straightforward. Yeah, reliability. General pattern that we go ahead with is a circuit breaker. Circuit breaker is one watch tower kind of a thing that you have between the services. When it is sending requests to the upstream systems, it will keep a watch on how many failures are happening for the request, and it will slowly stop sending the request to that service and start sending to other service. And it will constantly, after some time, after a delay, it will start routing few requests to that service, and it will see if the service is healthy or not. If it is healthy, it will start sending out full traffic to the service, or it will fall back and have its own fallback mechanism. So Netflix has come up with an amazing circuit breaker library, and they have open sourced it. Hystix, it's called. I think if you are dealing with microservices, probably you might have heard about this. Even if you have used it or not, I'm not sure. But Hystix is one popular library that you can use for circuit breaker implementation. Any questions here till now?
Yes, we have, I think. Would you like to take them now, Akhil, after the session? I think we are almost done.
Yep. Yes, that would make sense. So we are running out of time. I'll be really quick now. Infrastructure patterns, how we are going to deploy your services now. You can deploy multiple services per host, where you have one hardware host that has a shared hardware, and you deploy multiple things into that. This has the resources will be shared among hosts, but the concern that come up with is that you need to deal with a lot of compliance issues here, because if you're dealing with health related data or personally identified information type of data, you have to abide to few regulations or compliances that the state or the country will impose on you. So they might tell you to use a dedicated host. So you can't go ahead with this type of deployment patterns for you. And then next you have single service per host. Yes, you have only one host deployed on one service deployed on one host. Totally, absolutely isolated. But the drawback is that your resources are not very optimally utilized. Sometimes you end up giving unnecessary resource to few services which they might not need. And then another deployment, we have a serverless deployment. You might have heard the names of Dynamo, Lambdas, Dynamos, SQS, SNS, and all. The serverless deployment doesn't mean there is no server. There is server, but the server is managed by the cloud provider. You don't bother about the server. You don't bother the server going down or configuring the server. That is configured and maintained and patched, or whatever security updates are coming to it or maintained by the cloud providers. You only leverage the computational power of it. But server is still there. As a term says, it's not serverless. It is, I would rather call it maintenance-less server deployment. I would call maintenance-less server deployment. And then you have a service deployment platform where these things like the Docker swarms, the Kubernetes, and Cloud Foundry or the AWS Beanstalk, you have the whole deployment service deployment platform. You deploy everything as one chunk. The drawbacks of this is like not all deployment platforms give what we need. So the deployment platforms that the Beanstalk has designed might not be compatible with the database or whatever you are using. So that's a trade-off you need to think about. A service per container again. So again, this will give you absolute power of scaling up and down and proper encapsulation of technology inside the container. You can have multiple containers on a VM. So very optimal utilization of the resources that the VM will give you. And when you're going for a service per virtual machines, almost same as a container, but you have a very rich and developer-friendly infra deployments for the VMs that you have. Again, it's a lot of trade-off that you have to choose if you are going with service per container or service per VM. There are a lot of other concerns that you need to talk about because I've kept this thing because you pick the vocabulary out of this and you can go read about it. I'm not going to dive deeper on this thing. Again, another pattern that we see is the sidecar. If you remember what we discussed, the security implementations and the log aggregations, emitting logs, capturing metrics and all. If you think, why should your business logic bother about this? When you are starting a server, have your service, have your development concentrating only on your business logic. Let there be a separate thing that can take care of this cross-cutting concern, the side concerns like the security or access tokens validation, few basic rule validation, IP whitelisting and all. Let the sidecar take care of it. Your service, whenever it gets a request, it will just send it to a sidecar, and sidecar will decide whether this is a valid request or not, whether can it send it to the service B and get the process done or not, or whether should it deny it. You need not write in your business logic, why should I deny this request or not? Let the sidecar take it. So this is a sidecar pattern, one very popular implementation that we have in deployment patterns. And then one level above sidecar implementation is a service mesh, where you have multiple services which have sidecars. And imagine you have a 40 to 50 microservices in your suite of microservices. And each sidecar has its own set of rules. One need to validate on different things, other need to validate on different set of access tokens. We are connecting to multiple third-party products, so you can't take an overhead of maintaining each sidecar separately for all of them, right? So this is where a control plane comes in, where control planes only ownership is only job is to take care of maintaining these sidecars. What rules should go into what sidecar? And the sidecar will decide based on the rules that it gets. So Istio is one control plane product that people use, and Envoy is one very popular sidecar framework that is coming up, and a lot of traction is coming up in the open source community now. So you can read about this Istio and Envoy going forward. So this is about the service mesh. And yes, you have again communication patterns. You can have API gateways. So you are implementing multiple versions of. You need to support multiple versions of client. So suppose when a request is coming from a HTML, the browsers, you need to send them back an HTML response. But when the request is coming from the native devices, native applications like Android or Apple, you need to send them the REST API response, right? You can't send them HTML. So what you can do with this is you can have a API gateway in between, and let API gateway decide what request should go to what service, and then you reply back with appropriate response based on what type of the client it is. The other pattern in the communication is the backends for frontends, where you have different API gateways implemented for different clients. Suppose if your request is coming from a browser, from a laptop or from a browser in your mobile, it goes to a different API gateway and it will process the request accordingly. You have a separate API gateway that will deal with the request coming from native applications from Android and Apple. So yeah, and this API will gateway to again what routing should happen to what request and to which service should the request go. Yeah, I think this is about the communication pattern. So this is what I wanted to discuss in this in today's talk in the navigating the microservices pattern. And these are the list of references and the credits I would like to give in preparing this presentation and the concepts that I want to discuss and summarize. And yeah, thanks a lot. I'm Akhil, senior consultant at ThoughtWorks. If you want to reach me out, you can reach me out in LinkedIn, and this is my GitHub repo URL. And questions. I'm very sorry to overshoot by 19 minutes and 35 seconds.
Okay, Akhil, we have one question. So the question is like, when event one is resulting in 3 events in another service with higher branch factor, will put a limit on traceability here. Will we put a limit on traceability here?
No. Why do you want to put it? Please go ahead, please.
Yeah. I can read the question for you. When event one is resulting in 3 events in another service with higher branch factor, will we be putting a limit on traceability here?
Yeah. Yes, you shouldn't put any limit on traceability. So why do you want to limit your traceability? Because your one event that came to your service is branching out into 3 different events. So probably your tracing is happening for the first event itself when it is entering your platform, and you can send this trace ID in the 3 different branching out events, or probably you can add a suffix or prefix to this event and you can differentiate it into so that you can have a differentiation among the branching out events. But I would be inclined towards maintaining the trace ID that came from the first event and having it in the branched out events.
Hope that this question is answered to the concerned one. And yes, actually, we don't have any questions.
Cool. Yep, thanks a lot. Thanks for your time. I hope you got something out of this session, at least the vocabulary from this, so that you can go and read or talk in this grammar when you're talking about the microservices and all. Thanks a lot.
Thank you, folks. And thank you, Akhil, a lot. This session is very helpful and like it's very knowledge endeavoring. And folks, please fill out the feedback which is in the chat so that it would be useful for us for the upcoming events.
Thank you.
Thank you all.